Now let us start. So last time we stopped at this point, 1D, right? So let us continue in the question 2. Is it okay? Very good. Now, so remember, we are computing the implicit differentiation. It means that in this case, y is a function of x. Therefore, we should be careful whenever you do the differentiate, you differentiate y. Okay? So look at this. The left-hand side, so these are the related formulas we need to use. Okay, you can download the key on Moodle now. It is in the quiz, and in that section you will see the keys. I write it carefully, step by step, all the formula related to these problems, and follow that. Make sure that you understand. And if you have any question, come back here in the class, ask me. Okay. Now, let us remind ourselves about all the formulas related to this, right? So, in your point of view, which formula should we use for these problems? First, it is y cubed, where y is a function of x, right? So, it means that we need to use the formula u to the n. And what is the derivative of u to the n? Very good, thank you, Rami. N minus 1 and du over dx or u prime, okay? Du over dx, it means u prime, the derivative of u. So it seemed to me that you prefer this notation, u prime, okay? And what else? What is the other formula we should use here? Yes, e to the x, or in general, e to the u, right? We can use the chain rule, and what is it? U prime e to the u, okay? And in the very special case, e to the x, derivative will be e to the x. And you see that u prime in this case is x prime, which gives us number 1, right? It will be e to the x. So nothing new, just be careful. And the derivative of a sum, right? Derivative of a sum, f, or let us call it u plus v, derivative, it will be the sum of the derivative. Okay? I think they are all the related formula we need to use. Okay? Now, we do it slowly. From this equation, so we have that the derivative of the left-hand side, which is the derivative of negative 2y cubed plus e to the 2xy, derivative will be what? What is the right-hand side? Yes, 5x plus 2. They are equal to each other, so derivative of them should be equal. Thank you, Matty. So, therefore, now we need to do it slowly. on the left-hand side, okay? So it is a derivative of a sum. And here is a constant. The constant, we can take it out of the derivative. Therefore, the first term becomes the derivative of what? Yes, very good, but let us do it slowly. It will be derivative of y cubed, and the constant, we just rewrite it. And the same story here, e to the 2xy, the whole thing's derivative. And the right-hand side will be 5 times, what is it here? Very good, thank you. Very slowly, right? So let me get some space here. Oh, interesting. I don't know, I cannot continue from here. Let us erase this part. Ignore this, please. Okay? And let us continue here. Now, y cubed, derivative. So we should use this formula, right? It gives us -2 times what? Yes. And very good. And yes, y prime. Don't worry, just say it out loud. Thank you, Carrington and Gary. So, and in this term, e to the something, right? According to the formula, it would be the derivative of the power times e to that power. Okay? Applying to this, what do we have here? Let us do it slowly. It will be 2xy prime times e to the 2xy, right? And the right-hand side, 5 times derivative of x, which is 5 times 1. It will be, yeah, just 5. That's it, right? At this point, the first term is easy. We just rewrite it, okay? -2 times 3 would be -6 times y squared and y prime. Just rewrite it. And here, which formula should we use? Yeah, product rule. Very good. Thank you, Justini. Bless you. And from the product rule, what do we have here? Louder, please. Yes, 2 times derivative of x and yes. Very good. Thank you, Carson. And e to the 2xy, we just rewrite it, right? And the right-hand side. So just do it slowly. Very good. So now let us continue. This one, there's nothing new. We just rewrite it. And here, what do we have? Yes, 2y because x prime is equal to 1. And here, just 2xy prime because we don't know what y prime is. And we rewrite the whole thing. Now, we're looking for y prime, right? and it is here and here. So what should we do in this step? Yes, before factoring, we need to get rid of the bracket side here, right? Parentheses right here first by foiling it, okay? Because it is a sum of something times e to the that. And so foiling it, what do we have here? Very good. And very good. Okay, perfect. So now we need to find the common factor of y prime and then find it, right? Oops, sorry. Okay, it would be this guy here and here. So they are common factor. But before doing that, we can also get rid of this guy first, right? And what should we do to get rid of this? Very good. Thank you, Corrington. So if we subtract both sides by this amount, the left-hand side will be 6 y prime, y squared y prime plus 2x y prime e to the 2xy is equal to the right-hand side, subtract 2y e to the 2xy. Very good. And now we can factor it, right? It is y prime. It is y prime here. So when we factor it out, what do we have? Very good. And that's it. This is a product, right? The product. If we take y prime out of the parentheses, then 2x is left. And yeah, so we should be very careful right here. And the right-hand side is nothing new. Right, very good. So now we want to find y prime, okay? So what should we do to find y prime in this case? This is a product. And say it again, please. Very good. This is a factor. So if we divide both sides by this amount, we were able to find y prime. It will be 5 minus 2y e to the 2xy divided by negative 6y prime plus 2x e to the 2xy. And that's it. Okay? So is it clear? Is there any question? How about people on Zoom? Can you hear me clearly? And do you have any question about this?
I can hear you. I get it.
I have a question.
Sure.
I was just gonna ask when you're putting the quiz grades in.
Oh, the quiz, great. I'll try to do it before this weekend, before Sunday night, okay?
Okay, thank you.
You're welcome. I don't know why I cannot hear the speaker well today. The volume is quite small. Oh, it's better now. So we've done with the question 2, right? Let us continue with the question 3. Let us, come on. Okay, this is the question 3. We need to find the tangent line at the point 0 of the function f of x, which is x squared minus x minus 2 over x squared minus 4. Before doing this, before doing any math problems, we need to write down what we need to do, right? And the formula related to what we need to do. Okay, the tangent line, and it means that we need to write it in terms of an equation. And what is the formula of the tangent line?
Is it the y minus y1
Thank you.
equals, yeah,
Equal,
m
okay,
parenthesis x minus x1?
very good. Who was that?
Marissa.
I'm sorry, who are you? I'm sorry.
Marissa.
Marisa. Okay, thank you, Marisa. Very good. So, and in this case, what is m? The slope, right? Or it would be, in this specific case, what is it? The slope of this point. And
Is that the derivative at 0?
Perfect. The derivative of this point. The derivative of this point, which is, and this is our x1, right? This means the derivative at 0. And let us write out specifically here, y1. It means the function evaluate at 0, and x1 is 0 in this case, right? So from this, it means that we need to compute y prime, okay? And we need to evaluate the value of function at 0. We need to do 2 things, right? So let us do the easy things first, okay? So we need to evaluate the value of the function at 0. Okay? It means that we can use this formula right here. Okay? And what is it now?
Positive 1/2.
Perfect. Let us do it slowly. 0 squared minus 0 minus 2 divided by 0 squared minus 4, which will be negative 2 over negative 4, and it will be negative and negative. 4 is 2.2, so 2 cancel with 2, which gives us 1/2. Very good. So we have this value already, and we need to compute the derivative of the function, right? So let us do it.
So the 1/2 is the slope?
Yes. Oh no, this is 1/2 is the value of that function at this point, 0.
Okay, got it.
It's not a slope yet. But thank you for your question. So in order to compute the derivative, we can use the definition limit of f of x plus h minus f x divided by h when h approaches 0. That is definition. But now we study the formula. We can apply it, right? So now it means that we need to compute the derivative of this guy. But you see, this is a quotient. We can apply the formula rule immediately. But if we can simplify it, it is even better. It saves a lot of work, right? Make it simpler. So before doing this, let us try if we can factor it out and cancel it somehow, right? So in order, we simplify it. simplify it first. Now we just rewrite it, x squared minus x minus 2 over x squared minus 4. You can use the trick I told you. Here the solution will be, what is the solution of this one? Yeah, x is -1 and x is -2. Or you can just separate the variable in the middle. It will be x squared. So just do it naturally. How can we factor it? And how can we factor the numerator in this case? If you do it the way you normally do. Negative.
Minus 2x plus x, or plus 2x minus x, something like that.
Very good, yeah. Minus 2x plus x, which gives us negative x, which makes sense. Then this is another way to write the middle terms, right? Who was that? Is it Marisa?
Yes.
Thank you. And here, the denominator, we can factor it out, right? Using the formula, x squared minus 4, which is 2 squared. Okay. Now, if we do it slowly here, we can factor the common factor out. And what do we have in the numerator here? So let us consider the first two terms. This guy and this guy, okay? What is the common thing? X, very good. Thank you, Carson. If we factor x out, what do we have inside the parentheses here?
X minus 2.
Very good. X minus 2. And similarly, the second term, the last two terms, we can write it in the parentheses. The denominator, it becomes what?
X plus 2, x minus 2.
Very good. Thank you. Who was that?
That was A.
Say your name again, please.
That was Eddie.
Eddie. Thank you, Eddie. So now, again, the numerator. Can we factor it and make it the product of two things? Very good. X minus 2 is the common factor. And this, you can imagine that there's a number 1 right here. Therefore, if we factor x minus 2 out, and what do we have in this parentheses?
X plus 1.
Yes. So now you see, if you remember the trick I told you, you can save a lot of time factoring it, right? You can go from here to here if we know the two solutions. One solution is 2. The other is -1. So now, can we simplify it?
Don't you cancel?
Yes. Then, what do we have?
X plus 1 over x plus 2.
Thank you. Was it Eddie also?
No, that was Michael.
Michael, thank you, Michael. And before that was Marisa, right?
Yes.
Thank you. So now we have a simpler f of x, okay? Then we need to compute the derivative of f of x. And now it's simpler, so it helps us a lot. So if we want to compute f of x, prime, it will be the derivative of this one, the new guy. Okay. Now, remember, which formula should we use? Quotient rule, very good. So it means that it will be what is it? Thank you, Mehdi. Derivative of x plus 1 and thank you, Mehdi, and very good, thank you. Perfect. X plus 2 squared. Thank you, Mehdi. So now we do it slowly. Derivative of x plus 1. It is a derivative of a sum. And what do we have here? Yes, it will be the sum of the derivative of x, which is 1, and the derivative of a constant here gives us 0. Perfect. And this one, we just rewrite it. And the same story here, right? Very good. So now, can we simplify it? How does it become? One plus 0 simply becomes 1, right? 1 times x plus 2. If we remove the parentheses, what do we have? Yes, it is x plus 2. And this guy, yes, and divided by the same denominator. Okay. So now the numerator, we can simplify it further. And what do we have here? Perfect. 1 divided by x plus 2 squared. This is the derivative of any point x, right, of this function. So it means that we can evaluate the value at the 0 by putting this into the formula of this, which will be?
1/4.
Thank you. Who was that on Zoom?
Morgan.
Morgan, thank you, Morgan. And Maddie, Morgan, thank you. Let me see. Okay, now let me rewrite the formula of the tangent line is from a boat. We know that it will be y minus f at 0 equal to f prime at 0, x minus 0 here. And after some computation, we found that f at 0 was 1/2, right? We found it here, at 1/2. Or you can find f of 0 from this formula, give the same result, okay? So it will be 1/2 here. The derivative of this is 1/4. Here, x minus 0, okay? So now everything is easy. We just simplify it. So this one, the right-hand side, what is it now? Yes, 1/4x or x/4, it is the same thing. And can we get rid of the number -1/2 here?
Add it to the right.
Yeah, add 1/2. So this is an equation of the tangent line. So
Can we leave it in the first formula or do we have to put it in the second one?
You can leave it here. It is okay. I accept this solution. Okay,
Okay, thank you.
you're welcome. So the tangent line, we have seen it many times, right? So this formula is very important. If you, yeah, just write it down. I'll give you some points in the test. But having the final result is perfect. Okay? So is it clear? Very good. Now let us continue. The next question. What is it about? Oh, yes. Compute the first, second, third, and fourth derivative of the function y, y prime, y prime prime, y prime prime prime, y prime 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 prime, okay? Of y equal to cosine of 2x. So, not just notation before we do anything. Y prime prime prime, sometimes we write it y, open the parentheses, 3, instead of writing this, right? And we can write it y to the fourth here, right? So that we can compute the nth derivative of this. It's easier, just make it our life easier. So now, we need to compute y prime first, which is the derivative of cosine of 2x derivative, right? So what is the formula we should use here?
Chain rule.
Yes, the chain rule, or when you do it many times, you will know that, okay, before doing this, let me write it below here, the related formula. So cosine of a function u, where u is a function of x, okay? Then you can use the chain rule, or because now we do it many times, we can just write down the formula. It will be, do you remember? Yes, and u prime, okay? From now on, you can just apply this formula immediately, okay? Before that, we need to study chain rule and write it slowly, but now we get used to it. We can use it right here. And remember, when you would take the derivative of cosine, which gives us sine, and therefore, somehow we need to apply the sine of u formula, right? Derivative of the sine of u will be, what is it? Very good. Thank you, Andre. And you see me. Very good. So, now these are the two formulas we need to use. Okay? Let us apply here. From this formula here give us negative, what? Yes, times 2 or 2x prime here. Let us write it slowly. Okay? And 2x prime give us 2. Therefore, the final answer will be negative 2 times sine of 2x, right? Very good. This is the first derivative. And similarly, we need to compute the second derivative of y. The second derivative is the derivative of the first derivative. Okay? And the first derivative, we found it here, which is negative 2 times sine of 2x. Okay, right? Now, this is the derivative of a constant multiplied with a constant, right? A function. Therefore, we can take the constant out. Okay? Just step by step. And now, this is the derivative of a sine function of u, where u in this case is 2x. So what do we have? Louder, please. So first, the number negative, we just rewrite it, okay? Now, the derivative of sine of u here, we apply this formula right here, okay? Which will be? Yes, cosine of u in this case is 2x multiplied with? Yes, 2x prime. Very good. Okay, it's easy now. Cosine and negative 2, we just rewrite it. And here, 2x prime derivative, 2x derivative give us 2, okay? You can stop here, I'm okay with that. Or this, we can write it as negative 4 cosine of 2x, which is perfect, okay? Now, we need to compute the third derivative of y, okay? Which is the derivative of the second derivative. And the second derivative here, we found it here already, which is the derivative of 4 times cosine of 2x. Okay? And again, the derivative of a constant times a function, we can take the constant out, and which now it would be the derivative of this function. Right? And again, we use the formula. Derivative of cosine of u will be, yes, times. Very good. So now again, let us do it. The negative sign times the negative sign here give us positive, right? And so sine of 2x, and here there's a number 2 of this. Finally, we have perfect 8 sine of 2x. Okay? Do it slowly, step by step. We find. Okay, very good. The fourth derivative. Okay? It will be the derivative of the third derivative. And we found it here, the same story. So now you get used to it, right? Let us write it quickly. What is it now? Very good. 2x prime here. Then it will be perfect. 16 cosine of 2x. Okay? So far today we correct 2 problems very slowly and step by step. Review them, write the formula to a sheet of paper so that you can use it in the test. And tomorrow we will continue. And if you have any question, write it down. Thank you so much.
I have a question.
Sure.
Okay, are the homeworks going to be moved back since we aren't going to be learning anything, like any new material?
It's a good question. So is it okay if I move the homework 3.9, 10, and 4.1 up to mid Sunday night?
Yes, that'd be wonderful.
Yeah.
Yeah, that'd be awesome.
Thank you.
Okay, thank you.
You're welcome. Try to review the quiz. Thank you, and have a good one.
Thank you.
Bye bye all.
I was here. I don't know if you got me.
Who are you?
Jackson.
Jackson? Oh, thank you.
Yeah, I put it in the chat like when you're doing
Okay,
attendance.
I see. Thank you, Jackson. I corrected.
All right. Thank you.
You're welcome. You have a good one.
You too.
Bye bye, everyone.
Yeah.